All right, welcome back to part two of exponential functions. Okay, so here in this section, we're just going to look at the applications of exponential functions. Okay. All right, so we're going to look at compound interest. Compound interest. Okay, so we're going to look at some word problems here. Okay, so we have this formula: A of t equals p times 1 plus. Careful when you write the r and the n's. Make sure you can tell which one is an r and which one is an n. Okay, so don't write this part fast and then you can't tell. So top one is r, the bottom one is n. And then up here, I recommend you use parentheses here. That's an n times t. Okay, n times t for the exponent. Where a of t is the amount after t years. That's your final amount. Okay. P is the principal. So that's like your initial amount. R is your interest rate. This is your interest rate per year. And make sure that it's written in decimal form. Okay. So, because usually they'll tell you, oh, 3% interest. You have to convert that 3% to decimal. Okay. N is the number of times interest is compounded per year. Okay. And T equals the number of years, time. Okay. Okay. So final amount, initial amount, principal. R is your interest rate. N is the number of times your interest is being compounded in that year. That's the same N value. T is your time in years. Okay. All right. So let's take a look at calculating. Okay. So let's suppose that a sum of $1,000 is invested at an interest rate of, this is a big old joke, 12% per year. It's like barely 1% right now. Okay, anyway, I've never seen 12%. I think the highest I've ever seen was like 6 in my lifetime. Um, Never seen 12%. Okay, per year. Find the amounts in the account after 3 years if the interest is compounded. So we're going to do a few problems here. If the interest is compounded, here, let's do this. A, annually. So if it's compounded annually, how many times per year is this happening? If it's happening annually? Once. Okay, so if it says annually, n equals 1. Okay. B, semi-annually. Okay, so if it's happening semi-annually, then it's happening twice. So n equals 2, twice a year. Okay, if it says quarterly, then it's happening 4 times. D, monthly. So if it's happening monthly, then how many times a year is it happening? 12. Okay, and daily. So if it's happening daily, how many times a year is it happening? 365. Okay. All right, so let's go ahead and do this problem. Okay, so for all of these problems, we're going to be using the formula P times 1 plus R over N to the N times T. Okay, we're going to be using this for all these parts. Okay, so letter A, annually. We're going to do A equals 1,000. That's our principal amount, our initial amount. 1 plus our rate. Was it 3%? No, 12%. Oh yeah, that crazy rate. So 12% is the same as 0.12. N is 1 to the 1 times, how long are we leaving it there? 3 years. Okay, see here? 3 years. So T is 3. Okay, so if you punch this all into your calculator, this is 1,000 times 1.12 to the third power. Punch this into your calculator and you will get $1,404.93. That's if it's compounded annually. Okay, let's do letter B. Letter B, semi-annually. So N is now 2. Okay, so semi-annually, the interest is applied, compounded. Okay, so we get A equals, still our initial amount is 1,000. 1 plus the interest rate is still 12%. Now N is different. N is 2 semi-annually, so N equals 2 to the 2 times 3. Okay. And if you punch that into your calculator, you should get $1,418.52. Okay. All right. Go ahead and try letter C. Try letter C on your own. Quarterly. So N equals 4. Okay, so very important that you are able to punch this into the calculator and get the right numbers. Again, whenever students have this problem on the test, every single step that they're writing out for their work is correct, except the final answer, which tells me that they're not entering it correctly on the calculator. So go ahead and try doing letter C. Hit the pause button and then come back and see if you get the same answer. Okay, so it's still 1,000. 1 plus 0.12. What was it again? Letter C. Quarterly, so n equals 4 to the 4 times 3. Okay, so if you punch this into your calculator, you should get $1,425.76. Okay, and then go ahead and try it for D. D is monthly, so n equals 12. So it's still initial amount is 1,000. 1 plus 0.12 over 12 because it's monthly, so it's happening 12 times per year. 12 times 3. So if you punch this into your calculator, go ahead and do that if you haven't, and then check to see if you get this. And 77 cents. Okay. And then for daily, go ahead and see if you can punch this one in and get the correct answer. Daily is 365. Okay. So when you punch this in, you should get $1,433.24. Okay. So when we compare these, so clearly if interest is the more times that it's compounded in a year, the more money you make. Here it's only compounded once in a year. Here it's compounded twice in a year. Here it's compounded 4 times. Here every month it's being compounded. Here every day it's being compounded. So here when it's being compounded daily, we see that we get $1,433.24. So if you never invested before, what this is saying is that you had $1,000 and you let it sit in this account for 3 years, and your $1,000 made money for you. Okay, so it earned some interest here. Your $1,000 earned you for an extra $433.24. Okay. Okay. The other topic that we need to cover here is annual percentage yield. Annual percentage yield. Okay, so let's talk about what that means. This might be the first time for many of you. All right, that's also known as APY. Okay, so the APY, annual percentage yield, is the simple interest rate So it's the simple interest rate that yields the same amount at the end of the year. The end of the year, which is 1 year, the end of 1 year. Okay. So we need to know the formula for simple interest. Okay, so the formula for simple interest is A equals P times 1 plus R. Okay. So this is your simple interest. So here we're trying to find the interest rate for simple interest. Okay, so we're trying to find this R value right here. So what happens is in these previous problems, we weren't using the simple interest rate formula, right? We were using this compound interest formula. Okay, so we're using it, we're doing our calculations. Oh, how much is it going to make if it's compounded annually? So we use that formula, right? If it's simple interest, then you would use this one. And what happens is what you're doing is, okay, you're trying to figure out the annual percentage yield. So you're trying to find out the rate here where that will yield the same amount as those guys up there. So you're trying to figure out, okay, well, if this is compounded, this one's daily. So if this one's compounded daily and it makes $1,433.24, well, how much do I need to, what interest rate do I need to have here so that in simple interest terms, it'll make $1,433.24 as well. Okay. All right. So let's take a look at an example. Find the APY, annual percentage yield, for an investment that earns interest at a rate of 6% per year compounded daily. Okay. So the way you do this is you start with the first formula we were doing, the compounded and times per year. Okay, so we're going to go ahead and use the first formula. So we're going to use this one. Okay. All right. So this is what we do first. Okay. So A equals P. We don't have A. We don't have P. Okay. 1 plus the rate is 6%, so 0.06. Compounded daily, so N is 365. 365 times 1 year. Okay, so they don't say 1 year here, but remember, when we look up here, we're trying to find the simple interest rate that yields the same amount at the end of the year. So at the end of 1 year. Okay. So we want to know how much this makes in 1 year. And then we're going to set the equal to this one because we want to find out, oh, well, when will this be the same amount? Okay. So times 1. Okay. All right. So here we end up with A equals P times, punch this into your calculator, and we get 1.06183. Okay. All right. Then what we do here is now set this equal to the simple interest formula. Okay, because So here, this, if we're given some p-value, right, then when we do this calculation, this is going to tell us what we end up with at the end of 1 year, right? A is equal to this, right? And this A is going to be equal to the amount that we end up with at the end of 1 year, right? Okay. This is our simple interest formula, right? Well, we want to figure out the interest rate such that at the end of 1 year, this amount will be the same as this amount. Okay. We want to know, it's kind of like these guys at this bank are trying to copy them using their simple interest formula because who knows why? Because they want to, because this one's an easier formula, right? They're like, I don't understand this compound daily stuff. Okay, so, but they want to end up giving their customer the exact same amount, right? Okay, so over here, these two amounts should be the same, right? These final amounts A. Well, if these are the same, then this should be equal to this. So that's what we do. We set them equal to each other. This should be equal to this. Okay. And if they start off with the same initial amount, P, well, they cancel out because we can divide both sides by P. So we get 1.06183 should equal to 1 plus R. And then if you subtract 1, then R is equal to 0.06183. Okay. And you would write this as a percent. So that would be 6.183% would be your interest rate. So this bank, if they want to use this other bank that wants to use simple interest, they can offer this account at 6.183%, while this one is offering it at 6%. Okay. Okay. Go ahead and try this one. Find the APY. For an investment that earns 8% per year compounded monthly. Okay. So go ahead and try it. If you need to come back and check each step because you're like, I think I did this part, let me check. You can do that as well. So go ahead and hit the pause button and go ahead and try to set it up. So we don't know A, we don't know P. 1 plus R over N monthly, that's 12 times. 12 times 1. Okay, so this is just P 1.0067 to the 12th power. Okay, and then this is just P times 1.083. Okay, and so now we take this, set it equal to the simple interest formula. So now P times 1.083 needs to be equal to P times 1 plus R. The P's cancel out. 1.083 should equal to 1 plus R. Subtract 1 on both sides, and we get 0.083 should equal to R. 0.083 is the same as 8.30%. So that's the rate that this, if they want to do simple interest, that's the rate they need to set it equal to. Okay. All right. Again, if you have any questions, make sure you message me. I will see you next time.